Hello everyone, welcome to TryRide, the new era of learning. So myself Rafiq. Today we're discussing about clustering topic in machine learning. Okay, let's continue the topic. So clustering is nothing but it is a machine in machine learning. It is an unsupervised learning technique you use it to group similar data points into a clusters based on what the data. Okay, which deals the unlabeled data, right? Which deals the unlabeled data. So patterns, the main idea is that data points in the same clusters are more similar to the each than other to those in the those other clusters, right? They are different in the groups. Okay. So firstly, we know what is a cluster. Cluster is a task of automatically grouping a set of objects, right? A set of objects like data points, peoples, documents, etc. Things, what you can in such a way that objects in the same group called a clustered. A multiple we called as a multiple data points form a clusters, okay, or more simpler, it is each other than the those who are in the same group, okay, the same group. And why we use clustering? Clustering is a using when you don't have to label it data, when you don't have any labeled data, but still want to find the hidden structure of the patterns in the data sets. It helps in understanding the data. It helps in understanding the data and the patterns, right? Understanding data distribution, finding the anomalies of outliers, and data compressions, customer segmentations, recommendation systems like we use. Okay. The common clustering algorithms we all know about the k-mean clustering. Most proper method it is you can choose a number of clusters k and work well when the clusters are spherically and similarly sized. Okay, and hierarchical clustering, DB scan like a density based spatial clustering application, a mean shift like that. In example, we can say, in real example, we can say that if you went to super mall, right? If you went to super mall and you have a clothes, have a different cloth, like we have a shirt and pant and t-shirt and footwear, like grocery, sorry, accessories. So the all that necessaries were present in one group, like present in one shop, right? But those are different groups, right? Different categories. Like we divide the clusters. So clustering is the use of same type of the method. Like we using some techniques, clustering techniques to simplify the data into easy and understand the patterns. Okay. For the next thing, we can see again, clustering is nothing but organizing data into clusters that there is a high intra cluster similarities and low intra cluster similarities. Informally find natural grouping amongst the object. Why do you want to that? Okay, real application like we have the data and a real application like if I like say the shop market, right? Like we see a raw data of fruits. We using the algorithms as a techniques and we divide the data into, so we have a raw in raw data we have a guava, strawberry and apple in a group. Okay, by using algorithm it divides that into a cluster, like apples with separate data set, guava with separate data set, and strawberries with separate data sets. Like that the clustering methods or techniques are used. And we have the types of clusterings here. Yeah, we have five types of clusterings here: partitioning clustering and density based clustering, and distribution model based clustering, and hierarchical clustering, and fuzzy clustering. So for the first, we discussed about the partition clustering. The idea is nothing but divide the data into a non-overlapping groups of participation partition based on the similarities. Example, k-mean clustering we can take, and each data points belongs to the only one cluster. Okay, you must predefine the number of the clusters k. Works well when the clusters are spherically and equally sized. Okay, segmentations customer based on purchasing behavior, like we can use case like that. It is partition, and here we say density based clustering. So it is a form of cluster based on the areas of the high density separated by the low density regions. Okay, example DB scan, density based spatial clustering of the applications of with noise. We can say does not require the number of clusters in advance, can detect attributary. We can say like the spelling like ARBIT or ARY like that. Arbitrary shaped cluster is, so sorry for if the pronunciation is a little bit mistake. So clusters and identify the outliers, right? In mostly we use the geographical clustering or finding the earthquake especially. for the fraud detections. And distribution model based clustering is nothing but assume the data in is generated from a mixture of probability distribution. Okay, like we use example as a Gaussian mixture model GMM. Okay, it uses the statistical models to estimate the probability that a points belongs to the cluster. A point can be belongs to the multiple clusters with the probabilities, right? And like that divides the data into similar group specific groups. I, here we can see the hierarchical clustering. It is nothing but it is a structure-based tree, like we call also built a tree hierarchical of the clusters, like two types. It has a algorithm and divisive, like we called as a bottom up and top down, like we call them, and does not require the specific specifying the numbers of clusters. Okay, upfront visualization using the dendrogram like that. So it used to for the mostly we use for the grouping, organization, document clustering. We use for that. I explained in depth about the hierarchical cluster in the forward slides. And fuzzy clustering, nothing but data points can be belong to multiple clusterings with different degrees of membership, right? Useful for when the cluster boundaries are not well defined. Each data points gets a membership score for the each clusters. So here we can see the examples of the clustering gens. Um, Microarrays measures the activities of all gens in the different conditions. Clustering gens can be helped by determining the new cluster for the unknown gens. Like that, we can see the example of the how the clusterings can uh, an earlier clear application in the area. And we say why clustering organization because the data into the cluster provides the information, right, about the international internal structure and the external structure of the data. And cluster and clustering gens above. Sometimes the partitions is the goal, image segmentation, example, knowledge discovery in the data, understanding the rules and uh, recognizing the patterns, topics, etc. Mostly we known as the clustering also is also an unsupervised learning, right? Clustering methods or unsupervised learning technique use. We do not have a teacher to that provides example with their labels. We will also discuss dimensionality reduction and another unsupervised learning methods later in the course. And here we have the data set. We can see the what is a natural grouping among those objects, right? We have a one granny, one man. We all know it is and man, woman, and we have the men's in that group. So we have different genders here according to the age, right? So we want to divide them into a groups. For that, we can take the what is a natural group among the objects by clustering substance. We can take. We all know about this cartoon Simpsons. It is the most trending prediction cartoon in our world. So like that, I take this example. So take the Simpsons families. Here we have the Simpson families here. So from the Simpsons families, we take the school employees, like where the school Simpson schools employees like principal, like teacher, like that worker. So we divide the data. It is first object data Simpsons family here and Simpsons employees, right? And here we divide the how many females are there and how many males are there from the Simpsons. Okay, like that the data will be divided. So in other understanding, what is the similarity between those two objects? Like we can see, machine understanding can easily identify both the hair and the pattern and the structure of the face, but the nose and eyes or lips were the difference in the trigger. Okay, so the state of the being similar, likeness, resemble, and all has similarities of the future of the Webster dictionary. So we can see that we know it is when we see the real meaning of the similarity is a philosophical questions. We will take a more pragmatic approaches, right? We can see the approaches like different data and different figures. Like structure is same, but the little face structure is different. Remaining all the structure is like same. Like that, the data will be easy. It can be easily find the data like that. Both images are different. Like that, it's find by using clustering. So we have a hierarchical clustering, partition clustering, game engagement models, and number of clustering in front. So it is we can see the desirable properties of the clustering algorithms. Like we all know about the scalability in terms of the both time and space, and ability to deal with the different types and minimum. minimal requirement for the domain knowledge to the determine input parameters and interpretability and usability options. Optional as a user specific constraints. We can see the two types of the cluster. We also discussed that the partitional algorithm in a bottom up and or top down. Like that, we have two types of clusters. In a hierarchy, we can see the partitional algorithm and hierarchical algorithm here contains the same different data. Hierarchical divides the data into the tree-based structure, and partition divides the groups of the data, like which part according to the work, according to the similarities. Here, Simpson's family, mother, father, and grandfather, and siblings, or where we get into one greater family. And here, according to the school work, according to the purpose of the school work, the properties, they were their keeper and principal and teacher were get the in one data set. Like that, it divides the data. So here we can see how do hierarchical clustering use it. We can see the example bottom up, starting with an each item in the which own cluster finds the best pair in match into a new cluster. Repeat until all the clusters figure together. Okay. So here when beginning the matrix which contains the distance between the every pair of the object in the database. So we can see the d of granny and child equal to 8. We can see the equal 8, we have the same value equal to 8. You can see here we can see the 8 object is connecting to the both, and after that we have a granny at the same 8. Like that, the matrix will divides into the data. Bottom up algorithm, starting when each bottom up, like what we each it item in the its own cluster find the best pair to match into a new cluster. Repeats until the clusters are stops and are together. So consider all the possibilities of the match. So when they choose the best options in the clustering, so we can easily identify the clusters in a same signal ways. So considering the small ways, considering all the possibility matches, so choose the best match in the clustering. While doing the clustering, we can see the similar groups in that. So according to the age and the gender, we can separate the clustering in the bottom up. Like slowly the bottom will be increased by the up to the defy the classify the simple, we can see as simple data set in the dividing the group set. Like we can see in the second state the data will divide into a some more little bit. We have here 1 2 3 4, and choose the best one is 1. So here after we dividing into the three sets, we can choose the two better ones, and then in third we can see the tree based, like consider all the possibility match, we can choose the best one of here. Okay, like that we can partition data, and final output is like that. We have about the hierarchical, like that we see the final tree based data set like this, so we can easily identify it. So according to the computing distance between the clusters and single link, cluster distance equal to the distance of the two closest members in the each class. Like potentially we can say as potentially long and skinny clusters. See, data can take the one data to another data in different groups. Like in a iterations based, we can see the complete link. The complete link is nothing here. Difference we can see. We have the single link to the both each other and different groups we have. It is only linked with single link here data, right? But it completely linked when the data were across the data into the other data. Okay, we can see here we can see a group of data is outlier is there. We can see a group of data is connected to the one by one, but here we can see a group of data connected with outlier also with the midge of end of the data, like tight clusters we can say, as we can call it as a tight clusters. And here we can see the average links between the, we can see called as cluster distance equal to average distance of the pair, like the most widely used measure robust against the noise, right? So here we can see the high representation distance between the objects and the clusters, like single link and the average links. And here we see the summary of hierarchical clustering methods. No need to specify the number of clusters in advance, right? Hierarchical structures the map nicely onto humans in institution for the same domains. They do not know scale well. A time complexity of at the last of O(n) square, and when n is the number of the total objects, and like heuristic search algorithms, local optima, or the problems interpret interpretations of the result is very subjective. Uh, but we but what are the clusters in same place? we can determine the correct number of the clusters. However, things are rarely this clear, and unfortunately. So here we can see the data of this outlier is different than the hierarchical. One potential used for the dendrogram is used to detect the outliers. So here partitions is a clustering. So which is the each instance is placed is exactly one of the k-known overlapping clustering. Since the output is the only one set of the clusters, the use of the specific cluster decides the one clustering of the k, like the group of the data where divides into the multiple k-known clusters. So it is nothing but we can see the K mean clustering installation. We can see that we can found the best K. K means we found it is also unsupervised machine learning, and we decide initializing the K. We divide the groups into the clusters. In those group, we found a centroid point. We found a centroid distance to find the best K. Right. Here we can see we have the three centroid points of the K1, K2, K3. From that, we divide the and we do the iterations or overlaps to find the data set k-mean groups of the best k value by using clustering. See, we divide the cluster data and see the k1 is green and k2 is red and k3 is blue. Like the data set will be divided. And is after moving the reassign the objects like where the objects should go. Again, in iteration two and after the final iteration, we can see the same iteration after moving the center, reassign the objects nearest the center, move a center to the mean its news member. Like if we can see here the red is far away to the four lines, here the red is away from the data set. So we can merge into the green or into the blue. Like that, the iterations will be done. So up to the objects divide and come into the same adjustable comfort place at the clusters, right in the group. So algorithm k means decide on the values of the k, the number of the clusters, and the initializing k clusters randomly. So we can see that the steps were repeated and repeated like that. I do a video on k mean clustering in detail way. So we can see the Gaussian mixture models like this. The mathematical functions we're using Gaussian mixture to generate the framework. Like it is a data point given by the model. So Gaussian mixture model we can see here. And about the generative models of the Gaussian mixture model. So assuming we know about the number of the components as k and the weight of the w1, it is nothing but mathematical function. We can divide the data like this. So estimating the model, we see the estimated models of the parameter by using the formula, and after the GMM plus EM soft came in, we have the hard came in and soft came in. So we say the hard clustering and say about soft clustering. We can see the one each other the clusters. And about the final, we can see the divides of the cluster data. For the iteration one, we see that the clusters, it means randomly assigned, okay? And at the final iteration, it maybe data will be likely data will be separated. Like we can see the data of this set data set. So first the clusters where divides the data, like it outline the outlines, so the outliers where the separate the data into different clusters, and then it find the proper pair of the data sets to join the group to form a cluster based separate cluster group. Like that the data were divide the then the final iterations wait up to the they were the proper data outlier, like we see here the data in wait a second, like this we can see in distribution model based like the how the data will divide the draw a boundary line up to the data set like this. The method of the final iterations also done by like this. So here we can see this is similar how the outlier iteration starts and how it finished the proper way in proper outliers. And about the algorithm came in and GMM, we can see the difference between the it decide the class membership of the n objects by assigning the objects a k nearest cluster center, and each step assign the probabilistic membership and re-estimate the k cluster centrals, and it m step would like difference between the both are like similar. K-mean and GMM we use the similar steps where the change. if we starting, we take the k value as a member of the cluster and initialize the k cluster in the centroid by using parameter or centroid. After that, in the middle of the state, it will be little bit changed because in the step three, it decide the membership of the n objects and nearest cluster its center. And in GMM, it takes the each step like assigning the probabilistic member. Like after that, next it re-estimate the k cluster central by assuming the membership found the above the object is correct or not. In GMM, it takes a M step like re-estimate the parameters by using parameters on the probability membership. At the final output, the final step both are same. And repeat step 3 and 4 again and until the parameters go. Only the middle term of the clustering is difference between the K-mean and GMM. So here we can see in K-mean we use known as a famous technique is known as an elbow technique, where the that it changes at the k equal to 2 is a highly subjective of the two clusters in the data. The technique used for the determining the number of the clusters is known as mean finding, knee finding, or we called knee finding, or we called elbow finding, like where the cluster were divided into the set of the group data, they where the data is called two. So we find the proper and perfect k value here by using the elbow technique. So we can see the cross validation of GMM generative model, and we can see the data. And at the cross validation, we can see finally international validation and external validation like suitable match known as categories. So we can see the clustering divides like this. So forming the cluster is nothing but dividing the set of data in different forms, okay, to form a perfect group of data, right? Uh, I hope you guys are understanding about this clustering. Okay. Thank you for all. That's it for today.